recording and turn on your mic. Hello? Testing? Great.
In one of those happy moods this evening, right? All right, welcome everybody to the Los Alamos Faith and Science annual meeting. A couple of things. I'm going to go over the first part of the agenda very briefly with you and then introduce James Carroll, who will give us a wonderful about 45 minute presentation. And then we'll follow that up with the rest of our agenda. But first off, let me ask if anybody came in and didn't check in with Bob Ranowski, would you please go check in with him now? He's handing out ballots and checking off people's names, so that's very important for them. Okay.
You're saying he made a list and he's checking it twice?
And if you've been naughty nails, you ain't getting anything, baby. Okay, all right. Well, it's my pleasure this evening to introduce again Dr. James Carroll. He is going to give us a lovely presentation on religious transhumanism. And I can only imagine what all we're going to discuss in this topic. Dr. Carroll received a PhD in computer science with an emphasis on artificial intelligence and a minor in ancient Near Eastern history in 2010 from Brigham Young University. His dissertation was on the statistics of machine learning and the computer-assisted annotation of ancient religious texts. As a graduate student, he taught classes on artificial intelligence, Isaiah, the Book of Mormon, and the Pearl of Great Price in the Ancient Scripture Department. After graduation, he worked at Los Alamos National Laboratory, first as a postdoc. How many here worked first as a postdoc? Just checking, you know. And then as a scientist where he worked primarily on radiography. He is currently researching the application of machine learning and artificial intelligence for the analysis of radiographic image data. He attends the Unitarian Universalist Church of Los Alamos, where he teaches adult religious education classes on comparative religion and the Old Testament. His classes are available online, and we will make sure that people have that. It's on YouTube. So with that, please join me in welcoming Dr. James Carroll and religious transhumanism.
Enough to invite me back. All right. Last July, I gave a lecture on artificial intelligence here. You don't have to have seen that, but I will provide a link to that if you want to watch that and catch up. And we finished that lecture with this quote. This is how we ended the discussion. Let an ultra-intelligent machine be defined as a machine that can far surpass the intellectual activities of any man, however clever. Since the design of machines is one of those intellectual activities, an ultra-intelligent machine could design even better machines. These would then unquestionably be an intelligence, there would then unquestionably be an intelligence explosion, and the intelligence of man would be left far behind. Thus, the first ultra-intelligent machine is the last invention that man ever need make, provided that machine is docile enough to tell us how to keep it under control. I love how he says that last part, not that we figure out how to keep it under control, that's impossible, rather that it's docile enough to tell us how to keep it under control. This is how we ended the AI talk, and we made the comment that we seem to be headed towards something that could either be the best thing that's ever happened to humanity or an absolute nightmare, the worst thing. Religious transhumanism is a class of religious beliefs that take this idea and run with it in terms of their beliefs in God, their beliefs in an afterlife, resurrection, and that sort of thing. What we're going to do today is discuss religious transhumanism and transhumanism in general, but we're going to do it from a comparative religious perspective. Now, I teach comparative religion classes at the Unitarian Church. If you want to come to those, I put you on an email list and invite you. No one there is going to try to convert you. The great thing about the Unitarian Church is whatever you believe, you're welcome there. And we provide various services like comparative religion classes from a secular perspective, and you can come to those and come to nothing else, and that's great. We would love to have you. So that's the only plug, by the way, for that sort of thing I'm going to make. But you're all welcome to come, and don't feel like you'd be pressured. You can be a Mormon and come to that. You can be a Catholic and come to that, and still enjoy the comparative religion classes without pressure to convert to any specific belief. But what I mean when I say we're going to teach it from a comparative religion perspective is the goal of comparative religion is not to teach religion, but to teach about religion. And that's a very subtle, but I think important distinction. When someone teaches religion, they try to convince somebody to believe as they believe, to convert them to their beliefs. I'm not going to try to convert you to transhumanism or to religious transhumanism. In fact, I have problems with both of these ideas to some degree or another. But I have a history with this group. I was on the board of the Mormon Transhumanist Association for, I think, 3 or 4 years. I know many of the people involved in the movement, and I understand the concepts, and I find some of it compelling, but not convincing, if that makes sense. And in fact, I would argue that this is maybe why I qualify as an agnostic instead of as an atheist, because I don't know the answer to these questions. I remain uncertain, and religious transhumanism is one of the reasons I remain uncertain. But my goal here isn't to, again, convert you to that. My goal is to make sure you understand something that is complicated, confusing, and frankly, from the perspective of most people who aren't embedded in this, weird. And so I'm hoping to help you understand it. The goal here is understanding, not convincing or anything else like that. The topic inherently will have a lot of discussions of futurism. Futurism is this attempt to predict the future or guess what the future might be like. Futurism is hard, and it inherently comes with errors. Everyone who tries to do this, we can look back on their predictions and we recognize they are wrong. So, for example, H.G. Wells or the Time Machine or something like this. Historically, people who try to do this fail over and over again. The future is never anything quite like what they predict. So we're going to get a lot of this wrong. My focus in this class, again, from the topic of understanding, is to briefly discuss some of the things futurists might be predicting and how they impact the religious beliefs of religious transhumanism. I wish I could talk about the rest, like what do we think about those predictions? Are they accurate? Do we agree with them? What evidence is there for them? Do we think that they might come true? They might not. I would love to dive into those topics, but you gave me 45 minutes to explain religious transhumanism, and I've struggled with that all week. 40, even worse. I don't know how to explain something like this to someone who has, if you have no background in the subject, in 40 minutes and have it make sense. I don't know how to do that. And so I have to cut stuff out. I would love to spend a whole bunch of time on ethical considerations. Just because you can do a thing does not mean you should. And so just if we talk about predictions of what we could maybe do, we could spend a whole another hour on whether we should do A, B piece of this. I just don't have time for that. Because we have to cover, at least briefly, human augmentation, biotech, nanotech, AI, robotics, radical life extension, mind uploading, cryonics, digital resurrections, singularitarianism, the Drake equation, the Fermi Paradox, the great filter, the simulation argument, and if we have time, the new God argument. And we're not going to do that, right? There's no way we're going to get through all this. So I picked 1 or 2 of these things, and unfortunately, this topic is one that becomes more compelling the more you know about it. But at a brief overview, it can seem far out and crazy. But if I were to have more time with you, I think I could help you see why this is actually quite compelling. But I'd have to go into each of these topics. If you have a deep background in each of them, then seeing how they fit together and how they might spark a religious movement for somebody makes a lot of sense. But that's going to be very difficult today. So, because I knew I couldn't do this, and I'll show you this slide again at the end, what I've done is I've put together some additional resources. If you're watching in Zoom, I encourage you to come back later. If you're watching online, after I've recorded this class, this link will be in the description. If you're here, after, I will leave this link up and you can then find it at the end, because this will just be the last slide and I'll just leave it up. And then you can go there. And it's not finished. I am in the process, and it will be finished tomorrow when I post a recording of the class. I'm in the process of making this list of additional things you can read, from the books on this table, there's a whole bunch of them, to articles, scientific publications, presentations I've given or others have given, talks on different various subjects, TED Talks on each of these sort of topics, so that you can go and do all the stuff that I don't have time to do here in person. So what is transhumanism? And then we can talk about religious transhumanism. Transhumanism is a very simple idea, and I think everyone here, once I explain it, will be forced to admit that you're a transhumanist. Like it's obviously true. But it's the more radical vein of transhumanism that many of you would not agree with. So transhumanism is just the idea that evolution isn't done with us. Evolution brought us to where we are, and frankly, our technology impacted how we came to be as we are. We have less hair because we invented coats as a species. So our evolution has been impacted by our technology. The fact that we developed certain technologies also, and certain tools, then biased our survival towards those who were good at making those tools. So our hand structure, everything about us, has been optimized by evolution in a co-evolution with our tools and our technology. And so technological advancement is advancing and not done with us, and it's advancing in a way that is fundamentally changing what it means to be human. And I would argue already has fundamentally changed what it means to be human and will fundamentally change what it means to be human in the future. I think that's an obvious concept and one that everyone would agree with. For example, the hammer is an extension of lever for our arm that gave us extra power. We developed coats that let us live in snowy, cold biomes, glasses that let me see reasonably well, because otherwise I would be blind because I have a genetic condition that causes my eyesight to deteriorate. But yet I can see because I've got these glasses reasonably well. Language can you imagine human civilization without language? If you don't think our technology has fundamentally impacted what it means to be human, consider what it would be like to be a human without language. Language is a technology that allows me to have some concept in my brain, to convert that concept to symbols, to make noises with my mouth that then hits your ears and goes back into your brain and is retranslated, hopefully with minimal loss, back into those concepts. Sometimes with severe loss. I mean, I communicate with my wife, and neither of us sometimes realize halfway through the conversation that we understood what the other person was saying. We thought they were saying something completely different. And suddenly we realize we're having different conversations. And language is lossy, we make mistakes, but it's a miracle that it works at all, frankly. And then imagine that language written down. The magic of writing lets us transmit those ideas forward and backward through time, not backward, forward through time. And then the printing press allows us to print those ideas in mass and distribute them in mass. And then the internet has basically given a printing press to everybody, which is both good and bad. But you notice how technology has impacted what it means to be human and how it is doing so in the future and will do so in the future. Now, at this level, I think everyone's probably with me. If this is what it means to be a transhumanist, yeah, I agree with this idea. The problem is people who self-identify as a transhumanist take this to a new extreme, or what we would consider technological futurism, and they start talking about cyborgs and really radical AI and godlike superintelligence, and this is where they will probably lose most of you. That's okay. Again, the point here is to understand the concept of what they're thinking. Imagine if I could give you super strength, so that you could run and not be weary. You could walk and not faint. And you could lift really heavy loads and not be tired, like this DARPA guy is doing with this DARPA engineered tech suit. Imagine I could give you the smelling capability of a bloodhound. Or if you could sense electromagnetic fields the way a shark can. With those little dots on its nose, it can detect electromagnetic fields under the ground in the ocean. Or better yet, you realize you don't actually see light. You see three colors of light, and then what you see as different colors is the mix of these three different receptors firing at different levels. But bees can see into the ultraviolet. How many of you would like to see into the ultraviolet? I would. I think that would be neat. What if I could give you eyes that have 4 receptors, or 5, or 6? I mean, TVs would look silly at that point because they'd only have half the colors that you need. But what would it be like to see 6 colors? I don't know what that would be like, but I think it would be cool to find out. So this is where the idea that technology can actually fundamentally change what it means to be human, in one sense, by augmenting what it means to be human, by creating something that is superhuman in its senses, in its strength, in its abilities, and in its intelligence. For example, just for fun, I gave myself sonar vision. This was really fun. I put a little sonar thing on a blindfold, and I blindfolded myself, and I attached it to a little vibrator that I stole out of a PlayStation Joy-Con that broke. And depending on how close things were, it would vibrate at different speeds. And I started wandering around the house with this thing, and it took a few hours, but after a while, I actually felt like I was seeing. Because we've done this to people and put them in brain scans and found that the parts of the brain related to sight actually start lighting up. Like you can use sensations on your back will remap to sight if, after enough input, you've connected them to some visual-like 3D stimulus of the world. And pretty soon I was building this 3D map of the world based on, I'd move my head around and this thing would vibrate different amounts. And so they've used this actually to let blind people see. They put a little array of pixels on the person's back, and they'll push based on the brightness of the pixel, and then they put a little camera on the person's forehead, and pretty soon they can see. The brain adapts actually to that sort of input. So again, this is a really simple idea that I was just playing with for fun one day. But imagine if we could give ourselves, and there are people, by the way, who can click and find their way around, blind people who will click and actually use sonar to navigate. Humans can actually do that. What if we could get better at that? There are 4 potentially disruptive areas of technological change that have potential to radically impact human augmentation. DNA and biotechnology, nanotechnology, artificial intelligence, and robotics. Let's talk about biotech. Biotech, and especially DNA sequencing and editing and genetic modifications, these things have huge potential to do things like cure diseases. I told you I have a genetic eye condition that makes my cornea sag and then I can't see very well. It's actually genetic and it runs in my family. My brother has it too. I hope my son doesn't have it. We'll find out when he's about 40, or we could do a DNA test already and probably find out. But imagine if someone could give me a shot that injected a virus into me that went in and edited my DNA sequence just in that one place where it's broken, and cured my disease. Would I do that? And I think if I did that and I knew it was safe and there weren't a lot of other side effects, I would do it. Better yet, if I could ensure that and it's too late, we've already had a son, but if I could ensure that I didn't pass that genetic defect on to my son, I probably would have done it if it had been available. The problem with this is ethics, of course, because when we start talking about curing genetic diseases, everyone nods and says, yes, I want to do this. Well, one of the ways we cure genetic diseases, there's a mitochondrial genetic disease. And so if a woman has the mitochondrial genetic disease, she will pass it to her child. And so if she wants to have a child with a man, what they do, and have already developed and shown this technology in rats and things, I can't remember if it has yet been done for people, is you take the mitochondrial DNA from a third person and suddenly you have a child with 3 parents. Mitochondrial DNA from one, not the mother who has the genetic defect, and then the X and Y, and then the other X and Y chromosomes mixed normally from the woman and her spouse. And you end up with this 3-parent child. Again, the purpose of that was to cure a disease. So most of us are okay with this to cure a disease, but now we're pushing something where we start to get a little uncomfortable, wonder if we're playing God. And then it gets worse when we start talking about designer babies. What if I know that there's certain genes that make people more intelligent? What if I could give those genes to my son by checking a little box? At some point, we walk off an edge where we become uncomfortable and say, this isn't right. But it will happen, and the reason it will happen is because it's a gray gradient between things we all agree should be done, curing genetic diseases, and things we feel uncomfortable with at one end. And so we're going to wander through that gray area as we find the right place. It's definitely worth. So one of the things that my friends in the Transhumanist associations like to say is it's very important that we have these conversations because this stuff is coming and no one's talking about it. At least that's what they used to say about 2 years ago, and suddenly everyone's talking about AI. But we were doing this about 10 years ago because we saw this coming. Well, there's other related issues related to DNA, biotech, this sort of thing. Nanotechnology is a little harder because we actually haven't done this. Unlike AI, where we're starting to see, antecedents, nanotech is a little harder. But the idea here is to create machines that are very small on the molecular level, perhaps machines that can self-replicate, make another. So imagine I make one of these things, and I put it in a vat, and I program it and say, please make another, and 1 makes 2, and 2 make 4, and 4 make 8. And 8 makes 16, 32, 64, 256, and suddenly we're in an exponential trend where I get billions and billions and billions of these very small machines, and now I turn them loose and I say, please build me an engine, manipulating 1 carbon atom maybe at a time, and so I make an engine 3D printed by these little nanobots, made maybe out of carbon atoms, and so I've just made a carbon composite and or diamond strength piece of machinery. And I've done it with almost no human effort. This is nanotechnology. There's plenty of room at the bottom. It was a paper by, I believe, Richard Feynman, who started this idea. And then Engines of Creation, The Coming Age of Nanotechnology is the famous book by Eric Dressler talking about this idea. There's a copy up here. This has been predicted and has never come to pass. In fact, we can't even make a self-replicating machine that's as big as a house. I don't care how big you want to make it. We can't make it self-replicate yet. I see no reason why we can't, and so eventually this sort of thing could happen. And then, of course, the last is artificial intelligence. We talked about that last week. And robotics then allows our artificial intelligence, not last week, but last class, robotics allows us to embody the artificial intelligence so that it has the ability to manipulate the world around it. And of course, those things have the potential to have massive impacts. The one everyone is talking about today is artificial intelligence and the end of work. But if you combine robotics with artificial intelligence, you could, in theory, automate almost, if not every job every human has ever done. And then how does the economy function? And it's popular today to say, well, artificial intelligence isn't going to take your jobs. It's going to, augment your jobs. There'll be people working with AI that'll do this. And that's a popular thing that makes people feel good. And it's true for a while. But at some point, these things are just going to take your jobs. And we always said before, everything that, the loom it took some weavers' jobs, but it created more jobs than it destroyed, and we became more prosperous. That was true until we took every job. And again, then we're in a different world where we're going to have to do something different because production becomes cheap, but labor that people are willing to pay somebody for so someone can have money to buy the things that are being produced, that's almost non-existent. And so how do you redistribute labor in that sort of environment, or capital and goods and services in that sort of environment is not clear. Nanotech could have a huge impact on manufacturing and health. I talked about creating an engine out of individual carbon atoms precisely placed. But you could also have these little nanobots running around your body, fixing disease cells, destroying pathogens. Who needs vaccines if you can just destroy every virus that ever touches you because you have little nanobots running around killing them all? They can have huge impacts on health, longevity, and manufacturing, if it can actually be done, which leads to, of course, radical life extension. If you've never listened to Aubrey de Grey, you should probably listen to this guy give a talk. He's very strange, has this nice long beard. He's really fun to listen to because he's really excited about this idea of what he says is aging is a disease we should cure like we cure any other disease, cancer or whatever. And we're not talking about living forever as a decrepit old person. We're talking about never getting old, or if you are old, getting young again. And so this is what he's arguing for and what he wants to see research money put into. There's been all sorts of great research where they've extended the lifespan of rats by 2, 3, 4 times by changing a few genetic markers. Turns out it's not going to be so easy to do that for humans because the markers that make rats live longer, we already have flipped a lot of them, which is why we live longer than rats. So, but it turns out that there are things that live a long time. Turtles, right? They live a long time. It's possible. Our aging is a genetic disease. As we study aging, what we find is that aging is a genetic disease that accumulates through genetic drift, and it is weeded out in species with low predation levels. And that's why things like a turtle that has almost no predation lives a long time. But a squid lives 1 year. because it has very heavy predation. So any genetic change that allows it to breed fast and have lots of kids is selected for, even if that genetic change causes it to deteriorate over time. And so if we understand that and we combine that with genetic manipulation, you could probably solve some of these problems that cause these things to build up in our system, because clearly they can be solved. Certain species have done it. Okay, this is a rat artificial. Its hippocampus has been removed. When you remove the hippocampus, you can no longer create new memories. You can keep your old memories because the hippocampus isn't where the memories are stored, but the hippocampus has a role to play in generating new memories. So this rat has had its hippocampus removed, and then they put an artificial hippocampus back in, made out of a computer, neural networks and a computer that performs the function of the hippocampus roughly, and suddenly the rat can learn again. So now, if you have a damaged hippocampus, presumably we could do something like this for a human. And of course, Elon Musk, who is everyone's favorite billionaire to make fun of, has decided this sort of thing is very important, and he's created a company specifically to torture monkeys by implanting neural things in their brains so that they can control arms and things like this, is now seeking for clinical trials. He's asking for human volunteers for clinical trials to have little chips implanted in your brain to let you control a computer. And again, just like we did with biotech, he's starting with curing diseases, talking about people who are locked in and can't move. Like, I wouldn't want a chip with today's technology implanted in my brain, like, no way. But if I was locked in and couldn't move and I sat in a chair all day and I couldn't even change the channel on the remote, suddenly I might want this. And so he's seeking clinical trials for people who otherwise couldn't interact with their environment, so he can free them and let them interact with their environment. But the real reason he's doing this is because he's a transhumanist. He really is. And he's convinced that artificial intelligence is coming and it's going to take over the world. And unless we merge with our artificial intelligence, we will be left far behind and humanity will go extinct. And this is the same reason he wants to send us to Mars, to avoid possible human extinction. And it's the same reason he's really working on Neuralink. If you actually listen to him, he's a transhumanist who's interested in preventing AI apocalypse type human extinction. So again, I'm not telling you need to think like him, but his behavior makes a whole lot more sense when we know where he actually got these ideas from. Brain simulation is this other really fun one where what we do, and we've started to do this with worms, then with insects, and now we're working on mice, and we're pushing our way up into mammals. And the idea is to take a brain, slice it, and find every neuron and every neural connection, map those neural connections, and then plug them into a supercomputer, hit go, and then give it inputs like wiggling the mouse's whiskers and watching the brain light up. And then comparing that to real brain scans of real living mice and correcting the simulation until it's more accurate. You can imagine what that could do if suddenly I was doing that for a human brain. Which brings us, of course, to some of the weirdest things that some of these futurists have predicted. And again, most people making these predictions are atheists. This is not religious transhumanism. This is just sort of predictions transhumanists are making, the sort of conversations they're having. And I should point out, I think a lot of these might not happen, and if they or will happen much later than they predict. But I think some of them might happen, and it's at least worth having the conversations about the ethics, etc., which I wish we had time for. All I'm going to do is kind of cover the topics, but each of these has some potential to have happened, if not in our lifetimes, within that of our grandchildren's, and therefore we should be talking about them more than we are. Mind uploading is the general idea that if I can simulate a brain, what if I were to simulate your brain? If I could scan your brain at a high enough resolution, could I simulate your brain, and would it then behave like you behave? And if it did, would I have then uploaded your consciousness, your brain? What is the definition of self? And John, you had this whole talk on the definition of self, and this gets into those Buddhist concepts of the self, because if the self isn't what we think it is, well, then maybe it really can be copied. Maybe it really can be downloaded. Maybe, what does it mean? There's a great movie about this, by the way, Transcendence. Everyone should watch Transcendence. This is a movie that should be on your must-watch with Johnny Depp. The guy has a terminal disease. They scan his brain, and then they start asking him questions and scan his brain while he answers the questions, and then they tweak the simulation until it exactly mirrors his response, and then he dies. And then the question is the thing that was then uploaded, that they then interact with, is it really him? Or is it something else? And is it something scary? Or is it something potentially beneficial? And those are the questions explored in the movie. I love this movie. Y'all should go watch this. Cryonics is this other fun idea. This is for those of you who are too old to think you'll still be here when radical life extension comes around. By the way, who is that? There was a biologist who had learned. This is in Sean Carroll's book. I think what's the name of the book? Sean Carroll is a cosmologist, physicist, famous guy, has the right last name. In his latest book, he talks about a biologist friend he was working with, and his biologist friend was talking about how she was able to make stem cells, or make old cells young again by exposing them to certain environments, and she could turn back the clock on these cells. And so jokingly, he asked her, well, does that mean I'm going to live forever? And she said, no, you and I are going to die, but if you have grandkids, I would not be so sure. And then, of course, he made the comment, that doesn't mean we're going to live forever. It means you might cure aging, but you still haven't escaped the heat death of the universe, and off he goes as a physicist and cosmologist, right? But he has that throwaway line in there that I thought was very fascinating. You and I are probably going to die, but if you have grandchildren, I wouldn't be so sure, at least in terms of aging. Well, what do we do for the rest of us? Well, some very eccentric billionaires like to freeze themselves. And the idea here, of course, is that, well, freezing does a lot of damage, but you could still scan the brain and find the connectome. And if that's important for mind uploading, then maybe when the technology is ready, you could be uploaded into a new body, and some of yourself could be preserved. It's not the ideal solution, but if all else fails, cryonics is a great way to live forever, or to hope that you'll be resurrected by some future all-powerful scientist instead of a future all-powerful God. Let me talk about my mom for just a second. My mom died a year after my son was born, within a year of my son's birth. My son never got to know her. I would really love to introduce my son to my mom. I have, and I wanted to take pictures of this, but I forgot. And she has crates full of journals that describe her life. I started reading them, and I love them, frankly, because half of my life is in there. It's things I'd forgotten and stuff. It's great. I'm so glad she did that. If you don't journal, by the way, that this is something that, potentially your grandkids would wish you had done someday. But I don't think I'm going to really convince Sam that it would be a really exciting thing to go read his grandmother's journals. I find them interesting, but I don't think he would do that. So instead, I started an AI project. And I worked on it for a while, and it didn't work very well, so I abandoned it, but I plan on coming back to it. Let me tell you about my AI project. I'm taking a language model, and I didn't want to pay for GPT-4, which is probably why it didn't work very well. But I took a language model, and I fed it some of her journals. And then I said, don't pretend to be her, that's creepy. But answer in the first person. Introduce yourself as a memorial for her, and then answer in the first person questions about her life, and tell me how you know that for each question. So, when were you born? I was born on this date, in this place, to these parents, and that's part of my birth certificate, death certificate, and it's in my journal on page 27. Better yet, do that in my mother's voice, because I have recordings of my mother, and if I go to 11 Labs and I give it those recordings, it can clone her voice very, very well. If I have a language model, I can hand it that, and it will speak in her voice. And if I wait just a little while, I can probably make a nice AI avatar that looks a lot like her and speaks. And again, I'm not trying to claim that is her. It's a memorial of her that can answer questions about her life. And we can do this. Like, if you gave me a year and access to GPT-4, I could do, and 11 Labs, and you're willing to pay for it, you can do this. This is not unreasonable. It's within the realm of our existing language models. What happens 100 years from now, 200 years from now, 300 years from now, when I incorporate her DNA and any personality quirks that happen to be genetically tied so that it can match those? At what point does this memorial, I said, my goal is not to try some weird technological resurrection. I know we can't do that, right? But what happens 100 years from now? At what point does this become a being that it's clearly not the same as her, but neither would, if she were to suffer a brain injury, a severe brain injury, she would no longer quite be herself anymore either. but we would still consider her still her, because our concept of the self is really messed up, right? We don't know what the self really is. But at what point does this simulation gain enough fidelity that it actually becomes her? Now, I'm telling it explicitly, don't pretend to be her. Tell people you're a memorial that can answer questions about her life. But what point does it become so good that it is her? And at what point do we call that resurrection of the dead? You can start to see where the religious overtones start to come from. So when might some of this happen? Enter Raymond Kurzweil. He's a fun character. I love his sign, the singularity is near. He's leaning into the whole prophet role with the whole sign. What is singularitarianism? It's this idea that this is coming really soon and really fast. Again, I am not a singularitarian. I think he's wrong about some of these timelines, but it's this idea that it's coming really soon and really fast, and he bases that on this idea of the exponential. Moore's law has created exponential growth in computing performance. 1, 2, 4, 8, 16, 32, 64, and in 31 steps you have more than a billion. In 62 steps, you have more than a billion. Exponentials sneak up on you really, really fast, and they shock you at how big these numbers get and how fast these numbers get. This is an exponential y-axis on the left side, and he thinks he has found, he's a prophet by tracking trends, and he thinks he's found an exponential trend on a log plot, which is an exponential. And if you plot that thing out, by about 2045, 2050, the world's most powerful supercomputer can simulate every human brain that has ever lived. Now, two things are wrong here. The first is that his estimate of the human brain is about 1 billion times off in how hard that is to do, I think. But 1 billion times buys you maybe 30 years. So a singularitarian might say this is happening in 2030, 2040, and I would say, you're probably 2060, 2070. If exponential improvement continues. The other problem, of course, with Raymond's prediction is that he was absolutely wrong about the double exponential. This has more recent data than he had. And if I just draw a line through it, you can see where he saw the double exponential, right? Where he thought he saw it. If I can get my plot, here we go. Right here, his curve takes off like that, right? But this latest batch of data shows us that this is just kind of noise on what I think is a linear fit on a log plot, which therefore means a single exponential. That makes a big difference on when you start crossing lines. But again, I still cross Kurzweil's prediction for a single human brain about 2030. But this is his prediction for the brain. I think the brain is actually much harder to simulate. But again, his prediction for all human brains, for how difficult that is to simulate, you're talking what, 2075? Again, you may not be around to see this, but if you have grandkids, the world is going to get really weird. Their world is going to get really weird, assuming this continues. Now, Moore's law is not going to continue because Moore's law was based on shrinking transistors, and we've now shrunk transistors down to about the size of an atom, and if we shrink them anymore, we're going to hit quantum limits. We can't shrink transistors any further. But the power of the world's newest supercomputers is still increasing exponentially. You know how we're doing it? We're starting to make things that look a lot more like the human brain. Slower, but in parallel. They do lots of things all at once instead of doing one thing at a time really, really fast. They do lots of things all at once more slowly and with less power consumption, because we can do everything the human brain can do in something about this big around on about a light bulb worth of power. It's a proof by example that it can be done. We just need a radically different architecture, and we're working on changing those architectures. Those architectures were driven initially by computer graphics cards for gamers, and now they're being driven by artificial intelligence and by the drive to build more powerful AI language models. And so those are starting to take off, and as they take off, the exponential trend in the power of these supercomputers has continued, just for different reasons. We're no longer shrinking transistors. The simulation argument. This is like drinking from a fire hose. I'm giving you lots of like a 5-minute introduction to like 20 topics. I apologize. I don't know how else to do this. The simulation argument is by something by Nick Bostrom, who, by the way, says that playing with artificial intelligence is like a child playing with a bomb. It's probably a bad idea. We shouldn't do it. Nick Bostrom's fun. But he also wrote something called the simulation argument, which basically says computer games are getting really, really good, and they're becoming immersive worlds, and our NPCs, non-playable characters, these are the characters in them, they're becoming artificially intelligent and getting smarter all the time. I see no reason that in the future there won't be millions of these simulated beings. And in fact, he believes if we can simulate them, and if our power is, again, this is based on that exponential idea, everything hinges on that. If this is exponential, he claims that eventually the majority of conscious creatures will be in simulations. And if that is true, we can use some sort of weak anthropic principle sort of argument, a similar argument to say, we're a randomly chosen conscious creature, therefore what? You're probably living in a simulation. That's the way this argument goes. It's actually sort of compelling, but also kind of far out and weird. I don't know if I'm living in a simulation. I have problems with this argument. For example, I think it's true that we can create simulated realities at some point that are indistinguishable from real realities. And by the way, if you want to see something exploring this idea, The Matrix is the best kind of popular movie describing this concept. I think it's possible that we're going to do this. It's entirely also possible that the majority of conscious creatures do not live in those sorts of simulations because they might be really, really expensive, and it might be much cheaper computationally from an information theory perspective to have a conscious creature out in the real world and sit down in the simulation. So there might be more conscious creatures out in the real world, and therefore we might not be living in a simulation. But again, I'm agnostic. I do not know if we are living in a simulation. It is entirely possible. I see no reason why a simulation is somehow less real than real. The world is made out of math anyway. Anyway, so this is the simulation argument by Nick Bostrom. And if you go to those links, I will have links to each of these papers. Nick Bostrom's paper on the simulation argument, etc. You can read it for yourself. So that's been a whirlwind introduction to what transhumanism itself is. Now, most transhumanists are agnostic or atheist, but there are a subset that are religious. And you can see, I hope, the religious overtones in the things that we've talked about. Human improvement, just like we might believe that you'd be resurrected with a better body in a heaven where no longer with desire to do evil. There's paradise, prosperity on earth, version of paradise, return to the Garden of Eden. There's a promise of eternal life, of resurrection, of mind uploading, which might give you a sort of heaven prophecy. There's even this prophecy idea, and but this time by tracking trends, instead of revelation from heaven. But again, this idea of predicting the future, prophecy, and living in the idea that we might live in a created universe, which would imply, of course, that there is a creator, and then the idea that we are creating through AI this sort of future godlike intelligence, and maybe giving to ourselves eventually, as we merge with these improvements, godlike intelligence, giving ourselves godlike intelligence. So now that we've covered what transhumanism is, and I hope you can see some of the religious overtones or how it could be approached from a religious perspective, I want to move on and talk about the question, is there a God? But this time from the perspective of transhumanism and evolution. And I want to talk first, it's going to be a weird way to get there, but I think you'll see where I'm going in a minute. What does evolution say about the potential existence and nature of God? This is an illustration of our family tree. And you'll notice in this family tree that most of the things that are still alive, things out at the edge of this family tree, are very simple, bacteria. The majority of the biological mass in the universe is made up of very simple stuff. Evolution does not create complexity, or does not seek out complexity. It seeks out survival and efficiency. And simplicity is the best way to survive if you can. And so it will actually simplify something instead of making it more complex if it can and still survive. But what evolution does do is explains complexity. It doesn't seek out complexity, but it explains how complexity got here, because what evolution wants is survival, and one of the ways it gets there is by finding unique niches. And so as long as there is a niche that is not being filled by something else, evolution will push something to fill that niche. And what that does is it does create complexity. Not along the entire branch of the family tree, but along one or two of those branches. Because there's simple things already filling those niches. If you could survive now in an environment by becoming a little more complex, then you will, to fill a niche that those other simple things can't reach. So evolution is this beautiful explanation for the complexity of life we see around us. Not because evolution seeks out complexity, but because it does explain it. It explains how it got there from simpler antecedents. Technology is not created. This is a controversial concept, but I don't believe we invent technology. No one ever invented technology. In fact, no one alive today knows how to make a pencil. A simple pencil, the wooden one with the little rubber eraser and the metal thing connecting it, and then the graphite. No one on the planet knows how to make one of those things. We make those things because each person knows a piece of it. The person who drilled the oil didn't know how to make the pencil, but he knew how to drill the oil well to extract the oil. And then the chemist who turned the oil into the rubber, he knows how to make rubber, but he doesn't know how to make a pencil. The chainsaw, the lumberjack who cut down the trees, he doesn't know how to make a pencil, but he knows how to cut down trees. We create technology by working together, specializing and trading. And the technology we create is not invented, it evolves. We take existing inventions and we tweak them with new things that we've found, and we add slowly into the adjacent possible, slowly adding a little bit more as we move that boundary of what is possible out, combining one technology with another technology. These different technologies mate and have. There's a great talk by Matt Ridley called "When Ideas Have Sex." It's a TED Talk. You should watch this. It's great. This will also be in the links. And he basically describes the fact that these handheld devices are the merger of many separate technologies. Ideas just mated and merged and created something new, and then those ideas made and merged and created something new. And so evolution explains not only biology, but to some extent the concepts of evolution, explain technological innovation. So what is there a pattern that we see whenever evolution creates something complex? Well, let me tell you the story of life. We start out, possibly, we don't actually know this, but we start out maybe with RNA molecules that catalyze things. They catalyze chemical reactions, and if they catalyze their own chemical reactions, then they become self-replicating. This is the dawn of life. But pretty soon they get together with another molecule called DNA, and they offload the idea of data storage to DNA because it's more stable. So DNA stores the data, but then the RNA catalyzes the replication of the data. Pretty soon they develop a tool, and they build a tool like a cell wall, and they wrap themselves in this tool. But this is the tool they create. But they then merge with their tools to the point where they create something new, a bacterial cell. And then several single cellular organisms merge together to create these eukaryotic cells. And when they do that, they specialize. Certain cells specialize in power production, the mitochondria, and other cells specialize in ribosomes. And each cell, each subcell of this combination of cells specializes and trades with its neighbors, and it's able to create something more complex than either one piece could alone. And then many of these eukaryotic cells get together and create multicellular organisms. And those multicellular organisms specialize and trade, and each cell in the body will specialize on being a muscle cell or a nerve cell or a blood cell. And they'll all work together to create something beautiful, complex, and breathtaking, the human body. But along each step of the way, this happened by specialization, trade, and merging with tools. Each one creates a tool, merges with a tool, or merges with its neighbor and creates a more complex system. You are not a single individual. Again, I come back to this concept of self. By the way, go back and watch John's talk if you haven't on the self. This is slightly different, obviously, but it's the same sort of philosophy ideas. You are not a single individual. You are a collection of cells, and each cell is a collection of cells inside of cells, which is a collection of RNA and DNA and different things that have merged with their tools and merged with each other to create a grand collective system that is conscious. Notice that consciousness is existing on the level of the collective, not on the level of the individual. So there are patterns in complexity: cooperation, specialization, trade, tool use, collectivism. What does that mean if we were to create something superhuman? 1,000 years from now, 1,000,000 years from now, if you prefer, what will we be like? If we become more complex than we are now, we will do so, I argue, by the same patterns our great ancestors have. That means specialization, trade, systems, integration, and merging with each other. By the way, this starts to sound a little bit like the Trinity. It should. One yet separate, separate yet one. But there's some sort of concept of merging and growing with each other and connecting to each other. And the last question, and this is where I would love to talk about the Drake equations and the Fermi Paradox and all this other stuff that we just don't, and the great filter argument and all that stuff about aliens that we just don't have time to talk about. But of course the aliens are going to come into this, right? Of course they are. But think about this for just a minute. There are billions of stars in our galaxy and trillions of galaxies in the observable universe, and the universe itself might be infinite in size. If it's infinite in size, everything that can happen will happen somewhere. It is inconceivable, therefore, that we are the first to become intelligent and technologically advanced. And of course, Arthur C. Clarke made the comment that any sufficiently advanced technological power is indistinguishable from magic. Okay, where are we headed with this? If we are not the first, we have to then ask the question, well, where are they? That's the Fermi Paradox. But skipping that for a minute, there's also potentially an infinite universe that exists within maybe a matrix of multiverses. Multiple universes, all connected. I don't know whether it's possible to survive the heat death of our universe. I don't know whether it's possible to communicate between these universes. There's all sorts of cosmological questions we don't have answers to. But if the answers to those questions fall in just the right way, something superhumanly intelligent is guaranteed to exist. And it may exist outside of sort of space and time of our particular universe anyway. In fact, we might be a simulation it created, or maybe there's other ways to create universes, that we are a creation of that being's existence. It could also, if the universe, the multiverse goes back an infinite amount of time through some sort of infinite regress, it could have existed for all time. And have, and be a collective, again, of all these intelligences that have joined it. It seems almost inevitable that something like that would exist if the answer to certain questions surrounding the laws of physics fall in a certain way. I don't know if they will. We don't know yet. This is, again, why I'm agnostic. If it's true that, let me give you an example of where this might not be the case. Let's assume that the creation of biological life is extraordinarily hard. It's that first step that is almost impossible. Let's say if it's so improbable that every time it happens, it almost always happens once within every light cone. And let's imagine that the laws of physics do not ever allow you to escape your light cone. In that case, we are alone. On the other hand, if that is not the answer to and we may be doomed eventually, the heat death of the universe, even if we don't blow ourselves up, we might be doomed in the long run. If the answers to those questions are slightly different, and we don't know, then the answer to whether something like this exists, again, changes. And imagine what it would be like. One yet separate, separate yet one, infinite in its past history, infinite almost in its capabilities, possibly the creator of our universe. And it would have to probably be a compassionate being, because otherwise it probably would have never made it that far, would have destroyed itself, as we might, if we don't become sufficiently compassionate and loving, etc. So something loving, something compassionate, infinite in scope, and creation of yours. Now, again, if you don't believe this, that is fine. I am not trying to convince you. I haven't even convinced myself. But I am agnostic, and this is one of the reasons I am agnostic. And all the arguments I've seen the new atheists, for example, pose do not even touch this idea. And they fall short in large part because they don't touch this idea, because it's possible that God is a prediction of our existing theories, not something we need to explain the creation of the universe. Like, that actually doesn't work. Right? The universe is so lovely, so we need something more lovely and beautiful to explain how the universe could be here. But then we got to explain how that more lovely and beautiful thing ever got here. And you just created a bigger problem. But this idea says that something divine, something we would be tempted to fall down and worship if we saw it today, is a natural prediction of existing laws that we all kind of agree on. That's a completely different argument, and we're in a completely different ballgame. Again, so this not only tells us, I think, that God is possible, but also what sort of a God it might be. It would probably be natural, not supernatural. I don't actually think supernatural even exists. Although if we live in a simulation, it might have very different natural laws than ours, and it might have created our natural laws. Those are the laws it put into our simulation, and it could probably break them. But it would still be a being of some sort of laws of its own. It would probably have evolved from simpler predecessors. It would probably be hierarchical and collective in nature, and if it's individuals, it would be cooperative, probably benevolent, but it probably would not be pacifistic, because pacifistic things also do not survive the process of evolution. But cooperative and benevolent things do. Which brings me to one of the four horsemen of the atheist apocalypse, Richard Dawkins, in his book, The God Delusion, where he says aliens would be to us like gods, but they would have to come from somewhere and therefore not be gods. The laws of probability forbid all notions of their spontaneously appearing without simpler antecedents. They probably owe their existence to a perhaps unfamiliar version of Darwinian evolution, and therefore they would not be God, as he defines the term. The problem is Richard Dawkins doesn't get to define the term God for religious transhumanists, because this is exactly what they think God is. And he can't define that term for him. And frankly, as a scholar of comparative religion, they are right and he is wrong, in the sense that the concept of God is much bigger and broader throughout the course of human history than he wants it to be. He very narrowly defines God and then proves that thing is nonsensical, and it is, and then he thinks he's proved something interesting. But again, the concept of God has ranged all the way from the Hindu concept of pantheism, all of reality itself is God. By definition, that exists. Whether it's conscious or not is another question. All the way down to this kind of without body parts and passions Platonic God, or the prime mover or cause. And everything in between, from anthropomorphic beings who like to romp around and hit each other over the head, all the way down and through. And so the concept of God is much bigger than he wants to let it be. And again, what we've described here, imagine this sort of being. It would be very hard not to consider something like this divine. Now, at this point, my last slide and concept, if at this point half of you want to crucify me for blasphemy, let me give you two biblical paradigms in which you could see this story. The first is the Tower of Babel. And I know some of you are Buddhists, some of you aren't Christians, but Christianity is a big portion of our population. So let me use a biblical story here. The first is the Tower of Babel. Now, believe it or not, the Tower of Babel is about technological innovation. They create mud-baked bricks with straw, and dang it, that is so cool because no one had that before, and suddenly they can build towers that are really big. And they're like, man, this is cool. Let's build a tower so tall we can reach to the sky, and then we can actually invade God and take over. Because God was so mean to us, he actually created a flood and wiped us all out. We don't like that. We're going to make sure he never does that again. So we're going to build this tower so tall, it makes it all the way up to heaven, and we can invade God's home. And of course, the biblical authors are quite happy with that being possible. God doesn't say, you idiots, you can't do that. Right? God's like, now look at what they're about to do. Nothing that they have imagined to do will be restrained from them. And they're going to succeed. We have to stop them because we can't let them do this thing. So what are we going to do? Let's confound their languages and scatter them so they don't do this. The Tower of Babel is a story of mankind using technology to try to become God, or to fight God, or to replace God, or to take God's place. And God is not happy, and he wipes them out. Well, he scatters them across the face of the whole earth by confounding their languages. But now let's move to Noah's Ark. Noah's Ark is also the story of technology. It's the story of God's intervention with a group of people working with technology. Specifically, God warns them of a coming flood and then does not say, and don't worry, I'm God, I'll save you. He says, go out and build yourself an ark, dang it. And you got to do it, all your own self. And so Noah goes out and he builds himself an ark. An ark is a big technological achievement. And he gathers all the animals and puts the animals in the ark, and he saves not only himself, not only his family, but the animals. And of course, all those animals can't really fit on the ark. You know, there's problems with this story. That's not the point. The point is, in the mythological story, he saves himself, his family, and all of creation with technology. And he does so at God's instruction. And God does not just do it for him. But guess what? Then the rains come and the flood comes, and it's so dramatic, and he's in trouble. But then the winds come just right, and God blows him and takes care of him and carries him up on his hand. You notice God is involved in this whole thing, and he protects him and makes sure he's safe. His technology alone would not have done it, but God protects him and keeps him safe. And he survives the flood, lands on the top of Mount Ararat, and gives thanks to God for what he's achieved. Not thanks to himself or his own technology, but thanks to God. Nevertheless, it was his own effort and his own technological advancement that made it all possible in collaboration with God. So, really, we're talking about building something godlike when we do transhumanism. We're talking about that as man is now, God once was, and as God is now, man may become, is a famous couplet from a Mormon prophet. That's why, by the way, the Mormon Transhumanist Association is the largest religious transhumanist association on the planet, because they resonate with these concepts. But it's not something you have to be a Mormon to resonate with. Right? We're trying to create something godlike. We're trying to bring about resurrection, eternal life, the end of aging, uploading to a new world. Right? All this stuff. It sounds like bringing. It's the rapture of the nerds. It's a good name for the singularity. You can view that as trying to supplant God. If you view that through the Tower of Babel lens, I'm sure God is very unhappy. Right? If, on the other hand, you view that through the Noah's Ark lens, this is a balance of works and faith. Does God expect us to try to bring about heaven on earth, or just to wait for him to do it for us? Or will he help us if we try, but he expects us to try? Again, these are different ways you can view this. I'm not going to answer that debate today, obviously. I know many very good Christians who are very much Tower of Babelists, and they think all religious transhumanists are Satanists and we're all going to hell. I know others who are very convinced that if we don't try, God's going to just not help. Do you know the story about the flood? There was this flood, and the guy was on the house, and the boat comes by, and he says, no, God will save me. So he sends the rescue boat away, and he does this 3 times, and the flood rises so high that he drowns. And he gets up to heaven. He says, God, why didn't you save me? And God says, I sent you 3 boats. I know very good Christians who view transhumanism in that way. So again, there's multiple ways to do this. Here is, I encourage you, if you're interested, there is a Christian Transhumanist Association. They have a conference they do, I think, once a year. I'm not as active in that group. There's a Mormon Transhumanist Association. I know all those people. I was on the board there for a while. They have a conference once a year, and they invite critics. They invited an evangelical Christian to come and tell us all why we were going to hell one year to our conference. That was all a lot of fun. And we also invited an atheist to come tell us why we're all wrong about the existence of God. That was fun too. But they're very willing to invite anyone to come and argue with them or disagree with them. And again, the Christian Transhumanist Association, I know some of those people. There's some pretty nice people there. They have Facebook groups where you can get involved in discussion groups as well. And then you can go to this link now. If you're watching online, it'll be up there. But if you're here in this room, I have not finished all these links, but I'm going to try to put links to all these articles so you can go and read more at this resource. And I will just leave this up. And we are over time. But I started about 10 minutes late. I finished about 10 minutes late. This is about perfect, so I think I did that about right.
Thank you.
I would ask for questions, but you got more to do, so let's go on. And if you want, I'll be here after, and you can come ask questions.
The issue of artificial intelligence is really a hot issue right now, and the expectations, I mean, speculation is rife and it's exponentiating, but the speculation is that all of the jobs of humans will be taken over by artificial intelligence and smart machines. The thing I'd like to say is that Bruce Bueno de Mesquita wrote a book called Dictator's Handbook, in which he pointed out that people who gain control over countries, if they can have access to wealth without involving the population of the country, the population is not benefited. That they build a highway from the source of wealth, the mines or the oil fields, to the airport, they build palaces, and that everybody else lives at a subsistence level. What do you think the effect of artificial intelligence is going to be on the people of the earth if it actually comes and is fruitful?
This is related to Dutch disease. You familiar with Dutch disease?
No.
Dutch disease is the idea that certain economies that are based on natural resource, especially oil, end up struggling. They have very rich dictators and very rich elite classes. We see this in the oligarchs in Russia. But the people tend to be very poor, and they really struggle to create industry outside of that one sort of oil investment. We could have something very similar happen with AI. You asked what I think is going to happen. I don't know what's going to happen. I know that this is a problem. And the way we distribute wealth has to do with the incentive we create to work. We want people to work and produce goods and services because then we are all benefited. And so we incentivize work by paying people more. Whether we do that right or not is a whole other conversation of justice and issues, whether we have a good distribution. But whatever we do to fix that, we probably don't want to fix it in a way that completely de-incentivizes work, right? Because then everything would fall apart. That changes when you don't need human work to produce goods and services. Now who owns those, though? If rich billionaires create the AIs and then use them to produce the goods and services, they own all those goods and services. You could find very, very, very dramatic wealth inequality, and we could have very rich few while the rest of us wallow in some pretty severe poverty. That is entirely one possible outcome. Because no one would hire them. Why would you hire them when you can hire an AI? But if you hire the AI, then who gets the money? Well, the person who created the AI. And if the person who created the AI is this rich billionaire, he gets all the future money. But if he gets all the future money, who does he sell his stuff to? Because no one can afford to buy it. And it will even eventually not benefit him. Everything starts to collapse at that point. We will need completely new economic systems if this is going to work. We're going to have to think completely outside the box. Something like a universal basic income, probably. Now, I'm not saying that's a good idea now. A universal basic income might destroy the incentive to work.
We're going to take a second question.
Yes, second question. The point is I don't know, and it's going to be hard. We're going to need to rethink a lot of stuff. It's good we're thinking about it.
I hate to cut James off because he's so interesting, but we do have other things we need to discuss this evening. Was there one other question? Did I see another hand?
So the dark side.
Oh, yes.
We currently have a religious oriented kind of government using AI to target thousands of people. What about instead of this universal basic income, they just use AI to kill everybody?
By the way, I one of the things I left out was the ethics. There is a paper. Who did this? Bill who? Shoot. I may have this. Maybe I should. Maybe I should try to find this. These are my kind of extra slides. I don't have it. I don't think. Okay, so there's a paper called Why the Future Doesn't Need Us. and it will again be in the links. And it really explores the dark side. There's a dark side to all of this. Nanotech can get out of control and create self-replicating gray goo that destroys the world. You can make weapons that make nuclear weapons look like children's toys with biotech. You can kill billions and billions. You could probably exterminate mankind. There's a dark side to all of this, and the trick here is going to be, because some of these technologies are almost inevitable, the question is going to be, how do you create the good side of this instead of the dark side? Because there is an incredibly dark side to this, lurking right around the corner, and I wish I had spent more time on it, because as it is, I ran out of time. But
Okay, well, thank you very much. Please join me in thanking James.
and again, if you wanted to come and talk to me after, I've got books here. Peruse the books. Come talk to me after. That's all fine.